Mm-hmm.
These are kind of fun, actually. So this is the primary equation, although I'm sure they've taught you the other two also. In other words, this equation is really only for compounded annually. If I'm compounding continuously, it's this. It's a different equation. And notice that some of these questions we're looking at should be continuous. Whenever you have half-life, whenever you have something decaying, it's always decaying continuously, doesn't lose 10% every year. In other words, it's not compounding annually. But they did this on purpose, so they really only want to work with this equation for these problems. That's fine. They're really trying to demonstrate the use of logs more than anything. So have you done any of these, or you want to start with one?
Could we start with one?
Sure. So y is the population after it declines. So y is what?
Uh,
Y is 115,000. A is what?
120,000.
R is what?
0.012.
And am I subtracting it or adding it?
Subtracting.
Yeah, because it's decay. And it asks me how long will it take for that to happen. So now I have an exponential equation that I can solve. Okay? In other words, that's the way all of these problems unfold, is you fill in everything you know, and then there's usually one variable that you don't know. And that's what we have to solve for. So let's talk about solving this. What's the first step?
Would you just make it into a log?
Not yet. In other words, we do want to use logs, but we want to isolate that first. If I take the log of both sides now, this 120,000 kind of gets in the way.
So divide by 120,000?
There you go. So the first step is to get rid of that A by dividing by it. So that gives me 115 over 120. And that simplifies a little bit, but I don't care at the moment. Let's see, 1 minus that is what? 0.988, right?
Yeah.
Now what? Now I have an exponential equation. You cannot solve exponential equations if your variable is in the exponent without using logs. So what's the next step?
Putting it into a log?
What does that mean precisely?
Uh,
Not really putting it into a log. What we're going to do is use the algebraic principle that I can do anything to the left side of the equation as long as I do it to the right. So I'm going to take the log of both sides of the equation. And I can use common log or natural log. I want to use one or the other because that's what your calculator has on it. Or those two, you have a TI-84, right?
yep.
You only have two log keys. One of them's common, the other is natural. So we don't want to start using log-based fives. Those are tough to deal with. So natural log is huge in calculus. So let's use natural log. And as all I'm doing is taking the natural log of both sides of the equation. Now, using the principles of logs, what can I do?
No clue.
In other words, the goal is to solve for t. Well, I can't solve for t as long as it's in the exponent. But the reason I took the log of both sides is that allows me to bring t off the exponent down onto the algebra line. How so? What can I write next? In other words, this t now can go down there, right?
Yeah.
In other words, when you have the log of a to the b power, that's the same as b times the log of a. That is a super valuable principle to know for doing all of these problems, because almost every one of the problems we're dealing with has the variable in the exponent. So the only way to get it out of the exponent is to take the log of both sides and then move it down. So now we have the natural log, and what is that, 23/24 equals t times the natural log of 0.988. See how I got that?
Yeah.
Okay, and now you can solve for t. What's t equal to?
Just divide by the natural log of 0.988.
Yeah, so here's what we're looking at. And whether you use natural logs or common log doesn't really matter. I could have just as easily used common log. But like I said, when you get into calculus, you're always dealing with natural logs. So never too early to start. Get yourself comfortable with natural logs. And that's what t is equal to. And just so you know, whenever you take the log of a number between 0 and 1, you get a negative number. So both the top and the bottom are both going to be negative, right? You have your calculator in front of you?
No, I don't, sorry.
Okay. Do you want to take these to completion, or is this enough? They want you to come up with a number and round it to 3 decimal places. So might be at least worth doing one of them on your calculator just to make sure you're doing it right.
My calculator's at school, so I don't think I can, sorry.
Okay. Well, we'll just get to that step. In other words, you can take it from there as long as you're comfortable with being able to take it from that step where the thing I've squared. You know how to do that in your calculator?
Yeah, would you just type it in as is, really?
Well, here's how you type it in. The natural log, and you're going to have to put parentheses around that, divided by the natural log. You don't need parentheses around that. That's how you'd put it into your calculator. If you don't use these parentheses, it's going to do natural log of 23 divided by the number 24. So very important to use parentheses as long as you're going to leave that as a ratio. Okay? All right. Let's go on. Hold on a minute. I want to leave that formula up there. So the best thing for me to do is erase all of this. All right, the next problem. These get a little tricky setting them up, but once you kind of get the hang of it, you'll understand it a little easier. For number 2, the half-life of a certain substance is 42 days. How can I write that?
I don't know.
Well, what they're basically saying is that whatever amount you start with, A, that's always your initial amount, it's going to decrease by half. In other words, Y is going to be 1/2 A. And it's going to do it. We know it's a minus because it's decay. So I won't even write plus or minus. I'll write minus. Some are. Do we know what its rate is? No. But we do know what the time is, 42, right?
Mm-hmm.
In other words, that's what that first sentence translates to, is that the initial amount in 42 days becomes half of its original amount. And now notice that this actually is relatively easy to solve. I can divide both sides by a, so I get 1/2 equals 1 minus r to the 42 power. Well, one moment. So the question is what number to the 42 power is equal to 1/2? If I said 1/2 is equal to x to the 42 power, how would you find x?
42 root 40. I don't know how to say that.
Well, you would take the 42nd root of x. In other words, the one way to look at it would be I'm going to raise that to the 1 over 42 power, because now when I multiply that by that, I'm left with 1, which is x. So I got to do the same thing to this side. Now, in your calculator, so that's what we're going to do to both sides. Here, let me go back. I wrote x because I didn't want to confuse the issue by having two terms. But that's the next thing I'm going to write is 1/2 to the 1 over 42 is now equal to 1 minus r. You see why?
Uh-huh.
So all I've done is taken both sides, raised them to the exponent 1 over 42. Well, that means what about r? And r is what they're asking. Well, they're not quite asking about r yet, but we have to solve for r. And we really need a calculator here, but I guess I can bring up my Wolfram alpha. Well, hold on. Let's at least solve for r here. R is therefore, if I move r to the other side and bring all this other over, and this is what I have, right? You see how I got that from the one line to the next?
Uh-huh.
In other words, I move the r to the left, I move this to the right. All right, so whatever that number is, and I don't know that we want to spend a whole lot of time getting it, just because it'll take me quite a while to put that into my Wolfram alpha. The point is that you can solve for r when you have your calculator. Now, what's the general equation? Y equals a times 1 minus whatever this r is to the t power. That's the general equation, right? So they want to say, determine how long it will take 14 grams to decay to 3 grams. Well, what's the first thing that I'm going to write? What's y going to be?
3.
Yeah? What's a going to be?
14.
R is this number right here. So I'm just going to put it in like that. 1 minus 1. In other words, you can always do these things with your calculator. No point in us spending a lot of time doing arithmetic. That's what, and it's to the t power, right?
Yeah.
Well, notice everything's a number except this t. So I'm going to solve this exactly the way I solved number 1. It's a decay problem. It's the variables in the exponent. It was a two-step problem in that I used the first sentence, the half-life sentence, to figure out what R was. I got to do that. That R is some number that I don't know what it is originally, but I solved for it. So R is that number. Now I go back to the original equation, substitute R, and try to turn 14 grams into 3 grams in how many days? And it's going to be in days, not months or years. Because we solved for R based on a t being in days.
Mm-hmm.
So we're in days. Now, in actuality, with these growth and decay equations, t can be in any time element you want. It can be in years, it can be in months, it can be in days, it can be in seconds. But once you've determined it, you stick with it. In other words, this problem, t was in days. So my exponent was 42, and it was in days. And I figured out my R based on t being in days. So t is still going to be in days when I figure out the answer. And I want to make sure you know the next step, but I don't want to waste a lot of time doing arithmetic. So I'm going to make up some numbers here. 3 equals 14. Let's assume this number is 0.9. Okay? Without doing all of the arithmetic here. I'm assuming that that number is 0.9. You with me?
Yeah.
What's the next step?
Log both sides.
Nope. Got to get rid of that coefficient that's on the right side before we take
Divide by 14.
Yeah. So we got 3/14 equals 0.9 to the t power. Now what?
And then log both sides.
Okay, what kind of log?
Uh, Normal log, I guess.
Okay, log base 10 is fine. So we have the log of 3/14 equals the log of 0.9 to the t power. What's the next step?
Put t in front of the log.
Okay, what's the next step?
Divide by log 0.9.
Yeah, so t is equal to the log of 3/14, which we know is going to be a negative number, divided by the log of 0.9, which is also going to be a negative number. You always want to make sure that your t comes out positive. If you come out with a negative t, you've done something wrong, because there's no way t can ever be negative. Time cannot be negative.
Mm-hmm.
But we're fine here, because that's going to be negative, that's going to be negative, so we're going to have a positive answer. Now, this is not the answer, because 0.9 is not the answer. I made up that 0.9 to represent that, just because I didn't want to do all the math. The important part is that you know how to set it up and solve it, is that you can do it. So let's look at number 3. Okay with you if we go an extra 10 minutes to make up for the fact we started late 10 minutes?
Yeah.
Okay. So number 3, you drink a beverage with 120 milligrams of caffeine. Each hour, caffeine in your system decreases by 12%. How long until you have 10 milligrams of caffeine in your system? Well, always start with your basic equation. Again, we're talking decay, so I'm just going to deal with the negative sign. Growth is always the positive, decay is always the negative. So the first thing has 120 milligrams of caffeine. Which letter is that?
That would be A.
Okay. So we can write A as 120. Each hour, the caffeine decreases by 12%.
0.12. So 1 minus 1.12.
Yeah, and that tells us that our T is going to be in hours, right?
Uh-huh.
In other words, if T is 1 hour, then we're going to multiply the 120 by 0.88, right?
Mm-hmm.
T is in 2 hours, then it's going to lose another 12% in the second hour. So we're good on that. What should I write over here on the left? I can write that for the moment. Now I got two variables, right? Can't really deal with two variables. Let me think for a moment here. Do we have the full equation? I think we do right now. In other words, Y is the final amount. We know what R is. We know what the initial amount is. So what equation can I write to solve their last sentence? How long until you have 10 milligrams of caffeine in your system?
I don't know.
Let's always think of the initial and the ending. A is the initial, Y is the ending amount.
So why just be 10 mgs?
Yeah. 10 equals 120 times 0.88 to the T power. That's going to give us our answer. Because we only have one variable. In other words, we're going to solve this just like we've solved every one of them. What's the first step?
Log both sides, log base 10.
You keep forgetting that first step.
Oh, yeah, divide by 120 first.
Okay. So it's 1/12 on the left equals 0.88. See, once you get this isolated, now I can take the logs of both sides. I really can't do it if that 120 is over there. I've got to isolate the exponential part of the equation. And that's what I've done by dividing both sides by 120. Now, what's the next step?
Log base 10 both sides.
Okay, so I'm going to take the log of that and the log of that. Now what's the next step?
Why
Why did I take the log of both?
Move T to the front of the log.
Okay, so T log of 0.88 is equal to the log of 1/12. And what's the final step?
Divide by log of 0.88.
And that gives you T. And that way you can answer their question. Okay. All right, let's see if we can get in another one. The hardest part about all of these is really setting it up. In other words, these aren't easy questions. These half-life problems, you kind of have to get used to doing them. In other words, a half-life means that half of the original substance disappears. Well, instead of A, that means I end up with half A, right?
Uh-huh.
That's why we set it up that way, and that allowed us to solve for R. Well, let's see about number 4. The foundation has 1,200 termites, so the first thing I can write is 1,200 is A. Termites, this is a growth problem, grow at a rate of 2.4% per day. So what goes in the parentheses?
1 plus 0.24.
0.024.
Oh, yeah.
Make sure you don't get your decimal point out of place. There's my equation. In other words, this is a simple one. The termites grow at a rate, how long until the number of termites double? So give me
So why 2,400?
exactly. Next step.
Divide by 1,200.
Which means 2 equals 1.024 to the t power. Next step.
Log both sides.
Next step.
Move t to the front of log.
What's t going to equal?
It's going to be log 2 over log 1.024.
Yeah, notice both of those are going to be positive numbers, numerator and denominator. Whenever you take the log of a number greater than 1, you get a positive answer. When you take the log of a number between 0 and 1, you always get a negative. So we're good there. That's going to give us a positive answer. Okay? And this problem is relatively straightforward. In other words, the last two problems have been as simple as they get. We didn't have to solve for something else first. Number 2 has been by far the hardest problem so far. Let's see if we can at least get number 5 set up. Excuse me. I hit the wrong thing. The number of fruit flies in a room is tripling every 4 days. Give me as much as I can write about the thing. In other words, if this is my general, what do I know?
You know that A is 20.
Not yet, you know. In other words, we're going to have to solve for R here. They don't give us R. They're asking how long it'll take, but they don't give us R. So we've got to solve for R. So let's take their first sentence. How can I write that? The number of fruit flies is tripling every 4 days. What happens to A? What does Y become if it's tripling? Comes 3A, right? Whatever A is, it triples. It's growth. We don't know what R is, but we know that it triples in 4 days. So we know T is 4. Next step.
Divide by A.
Yeah, and that gets rid of it. And now what? Now we have an equation that's going to allow us to solve for R. Once we solve for R, we can go back to the original equation and we can answer how long it would take 20 to grow to 1,200. Well, again, this solution is to take the 4th root of both sides. And now we have 3 to the 1/4 power is equal to 1 plus R. So R is equal to 3 to the 1/4 power minus 1. With me?
Yep.
Now let's answer their question. Here's the general. We know T is in days. So now just work on the last sentence.
A would be 20.
Okay. Y
R would be 3 to the 1/4 power minus 1.
No. we're going from 20 to 1200. Remember, A is the start, Y is the finish. Y has to be 1200. We're going from 20 fruit flies to 1200 fruit flies. Okay? And we know the rate. The rate is that number right there. So let's just write it like that. 3 to the 1/4 power, which is a number like 1.5, minus 1. The whole thing to the t power. Well, we only have one variable there, and it's t. So first thing I'm going to do is divide by 20. So I get 60 equals this mess. So let's do that. So now we have 60 equals all of that. You with me?
Yep.
Next step?
Log both sides.
Correct. This next step?
Bring the t in front of the log.
So what's the t end up being equal to?
60 over 1 plus 3 to the
log of 60
yeah.
over the log of whatever that number is. And again, you need a calculator to figure these out, but that's okay. Again, that's a positive number, and that's going to be a positive number because it's this is a positive number over here being added to 1. So we're taking the log of a number bigger than 1. And, ooh, more. Well, we're not going to have time to do the last two. But let me just give you a hint. The last one is a half-life thing. So the way you're going to set it up is 1/2 A equals A times 1 plus R to the 12 years. Solve for R, go back, redo the equation once you've solved for R. These are fairly typical problems, difficult ones, typical and difficult, because you have to solve for R before you can answer their question. In other words, number 7, again, they don't tell you the rate that it decays. They just say that it goes down by half in 12 years. So this is one of those ones where you use A there and you use 1/2 A in place of Y. And then you divide both sides by A, and those two numbers, those two variables disappear. And you know what T is. T is 12, so you can solve for R. Once you've solved for R, go back, use it in your equation, and then redo the last sentence knowing what R is.
Okay.
All right, Jake, I'm going to let you go, and
Thank you.
good luck on this thing.
Yeah, thank you so much.
Sure. Bye.